Class, welcome to our second day of talking about parabolas. As we start looking at a couple of variations of our equations, let's just look at some of the basics that we remember from yesterday. Yesterday we talked about the fact that if you had an equation that had y equals x squared, and keep in mind these should look very familiar to equations that you saw in the past. These equations are parabolas that are going to open either up or down. We call that a vertical opening. When you had equations that said x equals y squared, these equations are going to be opening either left or right, which means they have a horizontal opening. Now, what we're adding in today is that these equations do not have to have a vertex at 0, 0. So we're going to bring in the vertex at hk. You'll notice that the h value is the value that is subtracted from x, and the k value is the value that is subtracted from y. Now notice that you have to pay attention to where x and y are, because in the second equation, when they are on reversed, you'll notice that now, again, h value is going to always be with your x. Your k value is always going to be with your y. Okay, before we get into some examples, I do want you to remember the equation says the k value is whatever is subtracted from y. The h value is whatever is subtracted from x. So let's say, for example, I gave you this equation, and I said that we needed to identify the vertex, which is the point hk. So we need to start with asking ourselves, what value is subtracted from x? That's going to be 3, so the h value is 3. Now, what value is subtracted from y? Since we see this written as addition, we need to remember this has to be thought of as subtraction. The value that is subtracted from y is actually negative 3. Generally, we remember that we're going to use the opposite of what is in the parentheses. Okay, so we're going to look at some examples similar to yesterday, but we're going to have to pay attention to where we're plotting points and counting correctly and things of that nature. So once again, I'm going to give you some missing information. I'm going to ask you to use that information to find everything else that's missing and write an equation and graph it. Okay, so we'll start with the plotting the points that we have. The vertex is at 6, negative 7. That's going to be down here. And the focus is at 4, negative 7. That's going to be here. Now, a couple of things to remember. Remember that the focus is always inside the parabola. Therefore, we know that this parabola has to be opening to the left. Okay, now let's talk a little bit about writing the equation. If we know that the parabola is opening to the left, then it's going to have to take the form of the y minus k squared equals negative 4a x minus h. We know that it's going to be a negative because it's opening to the left, and we know that equations that are opening to the left are going to have a y squared and an x. So now, let's talk about plugging into this equation. First, we can plug in our vertex. Remember that our vertex is the h and the k values. So h is the number being subtracted from 6. That means we're going to be plugging in 6 for h. The negative 7 is being plugged in for k. And remember that when you plug in, when you're subtracting a negative, we usually write that as y plus 7 squared. So at this point, our equation looks like this, x minus 6. The last thing that we need to write the equation is the a value. Remember that the a value is the distance from the vertex to the focus and also the vertex to the directrix. So if we look back at our diagram, we can see that this distance is 2, meaning that our a value is 2. Our final equation then is y plus 7 squared equals negative 8 x minus 6. And I'm going to bring that equation up here, equals negative 8 and x minus 6. Now, where's the directrix? As we said, the directrix is going to be outside the parabola, and we already know that the a value is 2, so to plot the directrix, we're going to go 2 units the other direction, and we're going to be drawing this vertical line through 8. So the directrix is the line x equals 8. Last thing we need are these latus rectum points. Now remember, latus rectum is one way to name it. We could also call this the focal width. The focal width, remember, is that 4a value. And in our case, that 4a value was this 8. This was that 4a value. So that means that we're using the 8 for the width through the focus. And as we kind of did yesterday, that means we're going to have to go 4 units each direction from the focus. So if we come back to our diagram and we find our focus again, this time we're going to go 4 units up, 1, 2, 3, 4, and 4 units down, 1, 2, 3, 4, and now we need to identify these points. Notice that these points in this problem are going to have the same x value. So both of these points are going to have an x value of 4. But for their y values, we had to add 4 and subtract 4. So my first y value up on the top is going to be a y value of 3, and down at the bottom, that's a y value of negative 11. Okay? Final step, draw the actual parabola connecting the focal width points and the vertex. And there's our parabola. Okay? So second example, similar, but with some different missing information this time. Okay, this time we're given, to start, we are given the focus, which is at 9, 5, so we'll plot the focus. And now we're given the directrix at y equals negative 5. Well, that's the horizontal line right down here. Okay, the question is, where's the vertex? Remember that the vertex is going to be halfway between the focus and the directrix. So to figure out where the vertex is, we're going to have to figure out what is exactly halfway between these two. Well, the distance from negative 5 up to positive 5 is a total distance of 10 units. If we go halfway between that, so if we go 5 units each way, that puts our vertex right here. So my vertex is actually at the point 9, 0. For the equation, based on the fact that the focus is above the vertex, this tells us that the graph is going to have to open up. Since it has to open up, our equation is going to have to be in the form of x minus h squared equals positive 4a y minus k. Remember, when the parabola is opening up or down, it's always going to be a y equals x squared. Okay, so now we can plug in our vertex right away. We knew that the vertex had an h value of 9 and a k value of 0. So that would be x minus 9 squared and y minus 0. What we still need, we also know the a value. We said that from the vertex up to that focus point was 5 units. So that means that our a value is 5. Our final equation then is x minus 9 squared equals 20. Y minus 0 is the same as y, so we can write the equation as x minus 9 squared equals 20y. As for the latus rectum points, remember that the focal width is going to be 4a units, and that 4a value is 20. So we're going to go 10 in each direction from the focus. So if we go back to this focus point, now this one's going to be a little bit harder to graph, but if we go back to this focus point, we're going to have to go 10 units this way. That's going to put me here. And then I'm going to have to go 10 units this way, which is going to put me way off the graph. So really think about these points. Both of these points are going to have the same y value this time. So we'll put in that y value of 5. I had to go 10 units to the left, putting me at negative 1 for my x, and then I had to go 10 units to the right, putting me at 19. And now I'm ready to plot my parabola as best I can, even though it's off the graph a little bit. Okay, Now in the next example, I've given you the equation, although it's not in exactly the form that we need. Generally, we look at these equations in the form of x minus h squared equals either a positive or a negative 4a, and then in parentheses, this y minus k. So the biggest thing I see here is that this side of the equation does not match. Our first step would be to actually factor this side of the equation to get it into the form that we're used to seeing. So if we start here and we actually factor out that negative 12, we could then rewrite the equation like this. So x plus 2 squared equals negative 12, y minus 2. Now, a couple of things that we know right away. Since this equation has a y equals an x squared, this equation is going to go either up or down. And since we have a negative 12, we know that this equation is actually, or this graph is actually going to be opening down. So keep all of that in mind. We also can identify the vertex right away. The value that is subtracted from x is going to be negative 2, and the value subtracted from y is going to be positive 2. So our vertex is at negative 2, positive 2, and I like to plot that point right away. Now, for the focus and the directrix, I'm going to need my a value. So if we go back to the equation, remember that this 12 was actually representing 4a, which means my a value was 3. Now, because this parabola opens down, that means that the focus is going to have to be below that vertex. So we're going to go down 3 points and plot the focus. That means my focus is at negative 2, negative 1. The directrix is going to be up 3 points, which puts my directrix at 5. So my equation for the directrix is y equals positive 5. Last, my latus rectum, the width, remember, is 4a, which in this case is, is 12, which means we will go 6 units each direction from the focus. So if we go back to this focus point here, and we go 6 units to the 1, 2, 3, 4, 5, 6 units to the right. And then we go 1, 2, 3, 4, 5, 6 units to the left. Oops, I didn't count that right. I apologize. Let's try that one more time. 6 units to the right. 1, 2, 3, 4, 5, 6. That's going to give me these focal width points of negative 8, negative 1, and positive 4, negative 1. And if you ever just want to check your math to make sure you didn't make any careless mistakes there like I almost did, just double check that the distance between these points is 12 units. That'll help make sure that you haven't made any errors there. And lastly, draw in your parabola, opening down, and we're done. Okay, a couple more examples. Now you'll notice on this one that this doesn't look anything like the forms that we're used to. So we definitely have a little bit of rewriting to do. But when you're starting to rewrite these, you've got to look for some key information. So right away, look for what's squared. You'll notice that we have a y squared, but we have an x that's not squared. So I always think of this as, this is in the form of y squared equals x. Now, equations that follow this form, x equals y squared or y squared equals x, these are the equations that are going to go open either left or right. But we don't know which yet, okay? Now, if we expand this equation a little bit, remember that we're looking at equations y minus k squared, either a positive or a negative, 4a, and then x minus h. So what we really need to do is make this equation look like that one, which means we have a couple of steps to do. Anytime we have this quantity squared, we're going to have to do some completing the square in order to get this to happen. And on this side, we're going to have to make sure we have everything factored. So a couple of different steps. Okay, back up to our equation over here. Since we want the y squared on the left-hand side, I'm going to leave my y squared minus 6y alone. But I am going to have to complete the square, so I'm going to go ahead and add in a blank to be ready to do that. Now I want my x to be on the other side of the equation. So right away I'm going to subtract that 4x. So the other side of the equation says negative 4x plus 9. Okay, now as for completing the square, in case you've forgotten, to complete the square, you're going to take your b value and divide it by 2, and you're going to square that and add it to both sides. So in this case, negative 6 divided by 2, that's negative 3, and negative 3 squared is 9. So I'm going to be adding 9 to both sides of the equation. Now I can go back and actually factor the left-hand side, y minus 3 squared. On the right-hand side, I have negative 4x plus 18. Now the right-hand side needs to be factored as well, and when we factor it, we want to make sure that that x is by itself. So on the right-hand side, we're going to factor out that negative 4, even though it may not go into 18 evenly. When I divide 18 by negative 4, I'm going to get negative 4 and a half. So now my equation looks like this. And because we can now identify this negative here, now we can go back up and decide that this graph is actually going to open to the left, not the right. So that's going to help us to be able to graph it. Once we've got the equation in the form we need, now we're going to go back and answer all these questions again. Okay, the vertex, what is subtracted from x? That's my 4.5. And what is subtracted from y? That's my 3. So we can plot that vertex right away, right here. Okay, for the focus and the directrix, we need the a value. So go back up to the equation. Remember that that 4 represents 4a, which means my a value is just 1. Since this graph is opening to the left, we know that that focus is going to have to be 1 unit to the left, which means my focus, and again I'm going to label that, my focus is actually at the point 3.5, comma 3. My directrix is going to be 1 unit to the right, which is going to put my directrix at x equals positive 4.5. My focal width or lattice rectum is 4a units long, and our 4a value is just 4, so we're going to go 2 units each direction from the focus. And back to my focus here, I'm going to go 2 units up, and I'm going to go 2 units down, and just pay attention to these ordered pairs, especially since we're dealing with some decimals here. So both of these ordered pairs are going to have the same x value as the focus, so that 3.5 is not going to change. But then the y values, we added 2, bringing us up to 5, and we subtracted 2, bringing us down to 1. And then finally, I'm going to change colors. Finally, we can sketch in our parabola. Okay, I did want to do a second example. If you feel like you have the hang of the completing the square and the factoring piece of it, feel free to skim past this one. But for those that would like to see just one more example, here's a second example where, again, this is not in the proper form. So look for those clues. We have an x squared, but we have a y without being squared, which means that we're looking at an equation that is in this form. Equations that are in the form of x squared equals y or y equals x squared, these are parabolas that open up or down. We need to rewrite this in the equation x minus h squared, positive or negative for a, and y minus k. So once again, we're going to have to do a little bit of completing the square with the x's. We're going to have to do some factoring with the y's. We're going to have to make sure everything's on the right side. So we'll start with, if we go back over to, actually, let's go back and erase these. So we'll start with the x's. We want to leave those on the left-hand side, x squared plus 4x. But since we're going to have to complete the square, I'm going to put in a blank right away. I'm going to have to move my y's to the other side, so I'm going to add 6y, and I have minus 10. For the completing the square, when I take half of the b value and square it, that's going to be a 4, which means I am going to be adding 4 to both sides. Then I can go back and factor the left-hand side. That's x plus 2 squared. And the right-hand side, I have 6y minus 6. Now I need to factor the right-hand side. So the left stays the same. On the right, I'm going to factor out the 6, leaving me with y minus 1. Because this is a positive 6, now I know that this graph opens up, not down. So we can keep that in mind when we're graphing. Okay, a couple of things right away. Remember that this 6 is representing 4a. If I divide 6 by 4, my a value is 3/2, or 1.5, so I know my a value. For my vertex, I need to look at what is being subtracted from x. That's going to be -2. What is subtracted from y? That's going to be 1. Since I already know that my a value is 1.5, I can actually find my focus and directrix right away, but I would recommend plotting the vertex first. So the vertex is at -2, 1. Here's my vertex. We know it's opening up, so for my focus, I'm going to go up 1.5 units. That's going to put my focus at -2 and 2.5. My directrix is going to be down 1.5 units, so that's going to put my directrix at y equals -0.5. My focal width is 4a, and my 4a value is 6, so I'm going to go 3 units each direction. Okay, so back to my focus here, I'm going to go 1, 2, 3 units. 1, 2, 3 units. You'll notice that both of these points have the same y value this time, so our y value is going to stay at 2.5. But my x values, I'm adding and subtracting 3, so I am at +1. And when I subtract 3, I am at -5. So there's my focal width points. And here's my parabola. Okay, last problem. Last thing I want you to be able to do is write an equation for the parabola given a graph. Okay, so some things to pay attention to. First of all, think about the direction. That's going to help you pick the correct equation, the correct format. So since this parabola opens up, we know it's going to be taking the form of the x minus h squared +4a y minus k. Then we can identify our vertex, and we can plug that in for h and k. So my h value is 0, x minus 0 squared, and my k value is -1, and when I subtract a -1, I can write that as y plus 1. So now my equation looks like this. The next problem is I don't know the a value. We saw this in the last example. Since I do not know the focus or the directrix, then I have no way of finding out the a value by using those 2 points. But what I do know is this point on the parabola. And if you ever have a point on the parabola, remember, substitute that in for your x and your y, and use that to solve for your a value. So if I actually take this x and this y, and I go back and plug in my x value of 2 and my y value of 0, I can now solve this equation for a. 4 equals 4a times 1. My a is 1. Final step would be go back and actually write the equation. So remember, the equation that we had was this, and now we know that the a value is 1. So my final equation will be x squared, or x minus 0 squared. 4 times 1 is 4, y plus 1. So tonight's homework will give you a little practice with a lot of the same steps, although the vertex will be moved. So you have to pay attention to where the vertex is in relation to directrix and focus. Look at writing some equations, finding the missing key information, looking for those focal width points.